Let's paint a picture here that is going to feel uncomfortably familiar for a lot of you listening. So it's Monday morning. You log in, you pull up your primary marketing attribution dashboard in Power BI or Tableau, and the entire revenue column is just throwing this massive cascading null error.
Oh yeah, the classic Monday morning fire drill.
Right. Your Slack is already lighting up with panic from the growth team. The weekend pipeline run failed. Those attribution models you spent, weeks fine-tuning, completely corrupted. And the culprit. It is almost never a massive system outage. It is always something silently, brutally mundane.
Yep. It's usually a single vendor changing just like a single line in an API contract without telling a soul.
Exactly. A platform like Meta or Google Ads, maybe TikTok or Salesforce, they quietly push an update over the weekend. They rename a field from, say, Campaign I to Campaign Identifier V2, or maybe they just introduce a new nested JSON object for engagement metrics, and your schema just wasn't built to parse it.
Right, or they drop a timestamp.
Yeah.
Or change a Boolean to an integer.
Yeah, and they certainly do not call you to apologize. And your ingestion layer, it doesn't care about their internal roadmap. It just crashes, or honestly worse, it silently processes total garbage data.
Which is the real nightmare. Because then it forces you to drop all of your actual analytical work just to perform essentially forensic accounting on raw JSON payloads, trying to reverse engineer some undocumented change. I mean, schema drift from external marketing APIs is, it's one of the most persistently expensive, yet somehow completely normalized data engineering problems that we face. We treat it like the weather, right? Like this uncontrollable force of nature that just routinely destroys days of productivity.
But the industry is finally shifting. We're moving from treating this as an inevitable disaster to treating it as an automated engineering challenge. And that is the mission for our deep dive today. We're pulling apart this really phenomenal architectural breakdown from datapro.news. It's dated March 25th, 2026, authored by Samuel Williams. It's titled An Agentic AI Bake-Off for Data Management.
It's a great piece.
It really is. So we are going to look at how 5 different agentic AI platforms attempt to solve this exact problem of schema drift.
And we're doing this specifically through the lens of you, the listener, the data analyst, and the analytics engineer. We aren't evaluating these platforms purely on their theoretical machine learning benchmarks. We are scoring them on practical reality.
Right, the actual day-to-day deployment.
Exactly. Specifically, the level of developer work required to actually maintain them. Because, an agentic system that requires a dedicated team of 5 ML engineers just to babysit its infrastructure, that isn't practically useful to an analytics team that's just trying to keep a marketing dashboard alive.
No, not at all. Okay, so let's unpack the baseline before we start comparing the actual vendors. The datapro.news article establishes what they call a gold standard benchmark. It's this idealized 6-step agentic ETL loop for handling API changes. And we need to understand what perfection looks like so we can see where the real-world tools fall short. So walk us through the mechanics of this 6-step autonomous loop.
Sure. So the first step is goal specification. Now, this is a big departure from traditional orchestration, where you define, the exact steps to take. Here, you define the desired state.
Okay, so you're not writing out the how, you're writing out the what.
Exactly. You supply the agent with the declarative specification. Often it's just a highly structured YAML file that essentially says, hey, maintain a daily refreshed, fully joined marketing data mart with the 100% downstream schema compliance, regardless of upstream API volatility. You define the boundary constraints and the success criteria.
Right, so you're giving it the architectural blueprint, not handing it the hammer and nails.
Precisely. So that leads into step 2, which is autonomous perception. The agent actively sits on top of your ingestion layer. When a payload comes in from, say, the Meta API, the agent doesn't just blindly pass it to a raw table. It evaluates the semantic structure of the payload against the known schema in real time.
Wait, so it's evaluating it mid-flight?
Yep. If it detects an anomaly, say the campaign 8 is suddenly missing, but a new field called ad set identifier appears, it intercepts that data midstream. It quarantines the anomalous records in a dead letter queue, so they absolutely do not corrupt your downstream models.
Okay, so mechanically, we're talking about an interceptor pattern. It evaluates the payload schema in memory before the right operation to the data lake is even committed. That's huge.
Huh.
Once it quarantines the bad data, what happens in step 3?
Step 3 is the reasoning model. The agent queries your data catalog, and it parses your directed acyclic graph, your DAG. It has to calculate the blast radius.
Right, the downstream impact.
Exactly. because if it alters the staging model to accept this new add set identifier, it needs to map out every intermediate table, every macro, every final visualization that relies on that specific column's lineage.
Okay, I buy the theory, but, in practice, production DAGs have hundreds of nodes, cyclical dependencies, highly custom macros. How does an agent parse a Jinja-heavy DBT macro without just hallucinating the dependency logic?
Well, that is the exact hurdle, and it brings us right to step 4, which is tool execution. See, it doesn't rely purely on its own internal reasoning to parse that Jinja. It uses MCP.
Ah, the Model Context Protocol.
Right, the new open standard backed by Anthropic, Google, and Microsoft. MCP provides a secure, standardized way for the LLM to interface directly with your actual build tools. The agent doesn't guess what the DAG does. It uses an MCP server to actively query your DBT project's metadata API, pulling the exact compiled lineage graph.
Oh, wow. So it's actually executing commands against the environment to validate its assumptions rather than just guessing based on text.
Yes, exactly. And once it formulates effects, like a new SQL model, to map the altered API fields, we hit step 5, which is self-healing.
Self-healing. Okay, how does that actually execute without breaking production?
It executes a localized compilation of that modified SQL in a transient sandbox schema to check for compilation errors against your specific data warehouse dialect. If it compiles successfully, it pushes the schema evolution to the destination, updates the pipeline logic, and then releases that quarantine data we talked about in step 2.
That is wild. And step 6?
Step 6 is the audit trail. Every API call it intercepted, every node in the DAG it evaluated, the before and after state of the generated SQL, and all the sandbox test results, they are all written into a highly structured metadata log.
So if we look at the underlying mechanism here, this isn't just some basic logic tree. This is dynamic routing and parsing. It's like having an intelligent network switch at a post office sorting facility, right? Like, it not only detects corrupted or weirdly shaped envelopes, but it opens them up, realizes the whole address format changed, rewrites the address to match your internal system, and logs the translation all before it ever hits the mail carrier's bag.
That's a perfect analogy. But it's an incredibly high bar. And as the source article makes painfully clear, absolutely no single platform on the market delivers all 6 of those steps natively out of the box today.
Right. Which sets up our platform comparisons perfectly. Since no single tool can execute the entire 6-step loop flawlessly on its own, we really need to look at how different architectures approach the problem. So let's start with the pairing that the article actually scores highest for purely structured data pipelines. That's the combination of the Airbyte agent engine and the DBT MCP server.
Yeah. For analytics engineering teams, this is definitely the most native, purpose-built architecture. Airbyte obviously handles the raw ingestion with its massive library of connectors. The critical component the article focuses on isn't the connectors themselves, is the context store.
Right, because just pulling data from point A to point B, that's a solved problem. Understanding what the data actually means, that's the real bottleneck. So how does this context store operate under the hood?
It operates as an active semantic registry. So when you ingest marketing data, you are constantly dealing with competing definitions, right? A concept as fundamental as an attributed conversion is calculated entirely differently by Salesforce, Meta, and Google Analytics.
Oh, absolutely. It's a mess.
So the context store uses probabilistic matching and metadata indexing to maintain a unified semantic layer.
So it's performing entity resolution before the reasoning engine even touches the raw data.
Exactly. The agent simply cannot write a reliable remediation script for a broken pipeline if it doesn't fundamentally understand that, say, the UUID representing a user in the HubSpot API maps to the exact same physical entity as a hashed email string in the Meta API. The context store forces standardization on the who and the what, so the LLM has a clean, deterministic baseline to actually reason against.
Okay, that makes total sense. That makes the handoff to the DBT MCP server much cleaner. If the Airbyte layer spots the schema drift and understands the semantic intent behind the new fields, how does the DBT side handle the reasoning and self-healing steps we talked about?
So the DBT MCP server is brilliant because it treats your transformation layer as a highly structured API that the agent can interrogate. When the agent proposes a fix to a raw staging model, it uses the MCP connection to trigger a dry run. It invokes what the source calls a fusion compiler.
Okay, explain the mechanics of this fusion compiler. What exactly is it compiling?
It takes the agent's proposed SQL, along with all your Jinja macros, and compiles it into the raw dialect-specific SQL required by your destination warehouse, so Snowflake or BigQuery, right? Then it spins up a zero-copy clone or transient schema, runs that compiled SQL against a sample of the quarantine data, and it checks the abstract syntax tree.
Oh, so it's actively verifying that the new data types match the warehouse constraints.
Exactly. It verifies that downstream models won't fail due to a random type mismatch. It essentially proves the fix works in a sandbox before it ever suggests pushing it to production.
That's incredible. And there is a metric highlighted in the article regarding this stack's perception capabilities that completely reframes how we think about pipeline monitoring. The source notes that this Airbyte and DBT combination can detect a 50% row count drop in a pipeline run that traditional monitoring systems actually report as a successful execution. How is traditional observability missing half the data?
Well, it's because traditional job-level observability is inherently superficial. It monitors the state of the infrastructure, not the state of the data itself.
Right. Did the server respond via...
Exactly. The orchestration tool pings the API. The API responds with a payload. The payload is written to the warehouse. The HTTP status code was 200 OK. The job is marked green. But traditional tools don't inherently know that an undocumented pagination limit was introduced by the vendor, which truncated the payload after exactly 10,000 rows.
So the infrastructure succeeded perfectly in delivering a broken file.
Precisely. Because the agentic system has that rich, historically indexed context store, it performs semantic data quality monitoring. It looks at the statistical distribution of the payload. It knows that on a typical Monday, this specific campaign generates roughly 20,000 rows. So when only 10,000 arrive, it flags an anomaly. Even though the infrastructural pipeline executed perfectly, it catches silent semantic data loss.
That is the silent killer for attribution models. Let's assign the developer work score for this native ETL combination, keeping our analyst listener in mind.
The datapro.news article scores this as low to medium.
Okay, that's not bad.
Not bad at all. If your architecture is already standardized on DBT and a modern ingestion tool like Airbyte, activating these MCP native capabilities is an incredibly high ROI initiative. The primary developer work is really front-loaded. You have to rigorously define your entities in the context store, because the agent's reasoning is only as good as the semantic clarity it inherits.
Okay, I see the power there, but, and I'm putting my analyst hat on here, I see a pretty glaring limitation. This entire architecture assumes a structured, well-governed environment. It assumes you can build that context store. But what happens when the API payload isn't just, an undocumented column change? What happens when a vendor completely revamps their architecture, deprecates their REST API, and starts pushing a massive, deeply nested, undocumented JSON objects into your data lake?
Yeah, that happens a lot.
Right. And Airbyte's semantic mapping relies on some level of predictable structure. It can't map a schema if the foundational logic of the payload is just completely alien.
You're absolutely right. That is the exact threshold where the native ETL tools fail. When you lose predictable structure, you need an architecture capable of parsing pure chaos. And that brings us to the second platform evaluated in the bake-off, Google Vertex AI agents.
This is the tool for the unstructured ingestion layer. When you just have a sprawling data lake full of raw, semi-structured JSON and literally no clear mapping rules.
Exactly. The source highlights Google's Vertex AI specifically because of the underlying mechanics of the Gemini models, namely the massive 2 million token context window. In this specific use case, that context window is not a parlor trick. It is a fundamental engineering requirement.
Let's contextualize what a 2 million token context window actually allows you to do mechanically here. We aren't just talking about feeding it a few pages of vendor documentation. We're talking about feeding it gigabytes of raw historical system output.
Yeah, imagine trying to understand a complex, undocumented, nested JSON structure. A traditional LLM with, say, 128K context window can look at a single massive payload, but it lacks historical reference. Vertex AI can hold the entirety of your multi-table marketing data schema, all of the legacy column names, every deprecated field, and 6 months' worth of daily raw JSON payloads from the API, all simultaneously in its active memory.
Wow. And the article refers to this capability as schema archaeology. Walk me through how the agent uses that massive context window to actually deduce an undocumented change. Like, mechanically, what is it looking for?
Let's say a vendor completely changes how they report engagement metrics. They nest them 3 layers deep in a new array with 0 documentation. You load the historical payloads and the new failing payloads into the context window. The model uses sparse attention mechanisms to map the statistical distribution of the scalar values.
Okay, wait, explain that a bit more. The scalar values.
Right. It looks at the actual data itself, the UEID formats, the timestamp structures, the float distributions, and it maps them across time.
Oh, I get it. So it realizes that even though the key name changed from click rate to like engagement.metrics bracket 0 bracket dot outbound clicks, the statistical distribution of the underlying floats is mathematically identical to the historical data.
Yes. It infers the schema evolution by analyzing the behavioral patterns of the raw data across time. It literally digs through the unstructured artifacts to reconstruct the logical blueprint that the API vendor failed to document. It can then generate the complex JSON parsing logic, say the specific JSON extract path functions in BigQuery needed to flatten that new nested array into your structured staging tables.
That is a phenomenal capability for unstructured data lakes. It really is like an archaeologist who can look at a pile of 6 months of messy, crumpled receipts and instantly spot the underlying pattern. But what is the developer work score for deploying Vertex AI in this capacity?
The source notes the interface is highly developer first. For an analytics team, the work score is medium to high.
Makes sense. It's not a plug-and-play UI.
No, not at all. This isn't a managed SaaS product where an analyst just clicks a toggle to turn on schema archaeology. It requires cloud infrastructure engineering to pipe the raw data lake output into the Vertex API, manage the token limits, and handle the asynchronous responses.
So the strategic architecture the article suggests is to really use these tools in tandem. You deploy Vertex AI at the very edge of the ingestion layer as the anomaly detector and the archaeologist. Once Vertex parses the messy JSON and deduces the new structure, it outputs a clean, declarative schema definition.
Exactly.
And then you hand that definition to the dbt MCP server to actually compile the SQL and execute the self-healing step in the structured warehouse.
It's a pipeline of specialized agents. The unstructured specialist handles the chaos, and the structured specialist executes the precision engineering.
Okay, I love that architecture. But introducing cloud-based LLMs like Vertex or Anthropic to the raw ingestion layer introduces a massive architectural roadblock. Marketing APIs are dense with sensitive customer data. We are talking about granular purchase histories, precise geolocation data, and highly specific behavioral signals. If we're giving a cloud-based agentic system the power to read raw JSON payloads just to look for schema drift, the security posture is suddenly terrifying.
It's a nightmare. It is the single biggest blocker to enterprise adoption right now. You simply cannot stream raw PII to a public cloud LLM endpoint just to fix a broken data pipeline. And that constraint leads us directly into the third platform evaluated in the deep dive, NVIDIA NemoClaw.
Right. And the article frames NemoClaw not primarily as an ETL tool, but as this critical enterprise security and governance fortress built on top of the open-source OpenClaw framework. And it highlights some baseline statistics for OpenClaw that should frankly terrify any data governance team.
OpenClaw, in its raw state, is highly vulnerable. The source cites a baseline defense rate of only 17% against adversarial instructions.
17%? That's nothing.
It gets worse. It also carries 4 active CVEs, common vulnerabilities and exposures logged in early 2026.
So if an agent is parsing raw external data, and that data contains adversarial prompt injections cleverly disguised as, say, campaign names or user agents, a 17% defense rate means the agent could be easily hijacked to execute malicious database commands.
Precisely. You cannot expose an unprotected agent to public data feeds. NemoClaw addresses this at the infrastructural level, using a mechanism called the privacy router.
Okay, explain the internal architecture of this privacy router. How does it programmatically prevent PII from leaving the enterprise network while still, allowing the agent to reason about the schema?
The privacy router functions as an ensemble model operating directly on your network boundary. Before any payload or query is sent to an LLM for reasoning, it passes through a fast, lightweight, encoder-only model. Think of a highly optimized version of BERT. This model performs high-speed named entity recognition and regex pattern matching. It is explicitly trained to identify PII, financial data, and commercially sensitive tokens.
So it's classifying the data at the packet level, basically.
Yeah. If the router detects high-sensitivity tokens, it sets a hard routing flag. That specific workload is immediately diverted to on-premises, locally hosted models, specifically the Nematron family of models running on the company's internal GPU clusters. The sensitive data never touches the public internet.
That's smart.
But if the router evaluates a payload and determines it only contains low-sensitivity data, perhaps an anonymized deep dimension table, it routes that workload to a faster, cheaper cloud model.
Okay, but this implies a massive infrastructural footprint. What is the developer work score for NemoClaw?
It is extremely high, maximum enterprise effort. The DataPro.news article points out that as of Q1 2026, NemoClaw is still only in its alpha stage. It requires dedicated, on-premises GPU infrastructure and a very sophisticated MLOps team just to maintain the routing logic and the local model deployments.
Yeah, I can hear the analytics engineers listening to this asking a very valid question right now. They're saying, look, I just need to fix the campaign EAD column so my Tableau dashboard updates. Why do I need to care about alpha stage, on-premise GPU clusters, and privacy routers? This sounds like an IT security problem.
They need to care because data governance is no longer just a passive checklist. It is an active gatekeeper.
Yeah.
If you attempt to deploy an agentic workflow using standard cloud APIs against a marketing feed containing GDPR-protected data, your compliance department will instantly terminate your project.
Right, they'll just pull the plug.
Exactly. NemoClaw and architectures like it represent the only viable path to getting compliance sign-off for autonomous ETL in highly regulated environments. The practical takeaway for analysts isn't that they need to build NemoClaw themselves, but they need to understand that this secure routing layer is a prerequisite for their agentic tools to even be allowed into production.
It's the infrastructure that permits the innovation.
Got it. But let's pivot to the analyst's actual working environment. NemoClaw is heavy back-end infrastructure. Vertex is developer-first cloud engineering. Airbyte requires deep DBT integration. None of these provide a native surface for the analyst who actually owns the business reporting. Where does the business user interact with these systems?
That is the specific domain of the fourth platform evaluated, Microsoft Copilot Studio. The article explicitly crowns this platform the winner of the accessibility category. It bridges the gap between the complex agentic actions happening in the warehouse and the business logic required by the analyst. And the integration strategy seems to be its primary advantage. These agents aren't siloed in some bespoke web app you have to log into. They are embedded natively into Excel, Power BI, and Teams, leveraging the existing Microsoft 365 graph architecture.
Let's trace a practical workflow to illustrate the mechanics here. Assume the Airbyte and DB layer we discussed earlier detects a schema change. Let's say Meta deprecated an attribution window field. The agentic system in the warehouse pauses the pipeline, quarantines the records, and drafts a SQL fix.
Right. And historically, the analyst just sees a broken dashboard, panics, writes a Jira ticket, and waits 3 days for data engineering to investigate.
Exactly. But with Copilot Studio functioning as the interface layer, the workflow changes entirely. The back-end agent pushes an alert directly into the analyst's Power BI environment. Without switching context, without writing a single line of Python or SQL, the analyst opens the Copilot chat interface natively within their dashboard. And they just interrogate the system in natural language.
Sure.
They ask, hey, why did the pipeline halt, and what is the proposed remediation?
And because Copilot has access to the MCP server logs from dbt, it essentially acts as a bilingual translator. It translates the highly technical Jinja and AST compilation results into actual business context. So it replies something like, Meta deprecated the 28-day attribution window. The backend agent proposes mapping historical data to the new 7-day window logic to unblock the pipeline. Do you approve this schema evolution?
Exactly. Copilot Studio functions as the human-in-the-loop review surface. It is not executing the heavy extract, transform, and load operations itself. It relies on the underlying data engineering stack to do the computation. Copilot is purely the orchestration and approval interface. Furthermore, because it operates within the Azure ecosystem, it automatically inherits the organization's existing Active Directory permissions and row-level security protocols.
So the developer work score for the analyst team here is very low. It empowers the business user instantly. However, the article highlights a significant architectural catch regarding governance.
Yes, the limitation is multi-cloud governance complexity. Copilot Studio operates flawlessly when it's interrogating Microsoft data structures or highly integrated backend systems. But marketing stacks are inherently fragmented. Managing the secure API handoffs and the identity resolution when the Power BI Copilot needs to pull context from, say, a bespoke Salesforce deployment or an isolated Google Cloud Vertex environment, that introduces significant architectural friction.
It's a fantastic translation layer, provided the back-end piping is already perfectly aligned. But that brings up the final edge case. Managed platforms like Copilot, Airbyte, and Vertex are designed for standardized, predictable enterprise environments. What happens when a company's data architecture is just completely non-standard?
What kind of non-standard architecture are you envisioning here?
Well, think of a massive legacy enterprise. Their marketing data doesn't just come from clean Meta and Google APIs. It flows through proprietary internal tools, legacy mainframes, and bespoke webhooks. A single schema change at the top of the funnel triggers this chaotic, nonlinear cascading failure across 5 different internal data products.
Oh, those are brutal.
Right. And some of those products require automated remediation. Others are tied to financial reporting and legally require human review before any SQL is altered. An off-the-shelf platform cannot orchestrate that level of bespoke conditional logic.
You're right. When you hit that ceiling of complexity, managed SaaS products break down entirely. You must build the orchestration layer yourself. And this is the focus of the fifth segment in the bake-off, the build-it-yourself kit, specifically focusing on LangGraph and Autogen.
Let's dissect the mechanics of LangGraph first. The source describes it as providing fine-grained control over stateful branching logic. How does it handle the cascading failure scenario I just mentioned?
LangGraph allows engineers to construct highly complex, directed acyclic graphs, where the individual nodes are LLM calls or tool executions.
Ah,
Crucially, it manages state. In traditional LLM interactions, the model is stateless. It forgets previous context unless you constantly re-inject it. LangGraph maintains a persistent state object that is passed and mutated between the nodes.
okay, so mechanically, if the system detects an API failure, LangGraph evaluates the state and triggers conditional branching. Branch A automatically rewrites the staging model for the marketing team. But Branch B detects that the altered column impacts a finance dashboard, halts execution for that specific lineage, and routes a notification to a human controller, all while maintaining the exact context of the failure.
Yes, it is programmatic orchestration of agentic behavior. And the article pairs this with Autogen, which introduces a completely different paradigm, conversational multi-agent architectures.
This is where we move away from a single omniscient agent and start spinning up specialized, localized agents that actually debate each other.
Exactly. You define distinct personas with rigid constraints. You spin up an engineer agent equipped with SQL validation tools and a business logic agent equipped with the company's revenue recognition guidelines. When schema drift occurs, the engineer agent drafts a remediation script. The business logic agent reviews the code and pushes back, stating, hey, if you implement this coalesce function on the revenue column, it violates Section 4 of our accounting standards. The agents iteratively debate, refine, and reconcile the code before it is ever executed.
It's simulating a peer review process at computational speed. That's amazing. But looking at the developer work score for LangGraph and Autogen, the article marks it as maximum.
Because there is zero managed infrastructure, no low-code UI at all. You are provisioning the compute, managing the memory states, writing the specialized prompts, and maintaining the API connections. It is a massive software engineering undertaking.
And my budget alarm is ringing just hearing that. Do companies actually need this? Because the DataPro.news article offers a very stark piece of practical advice regarding these bespoke builds. It notes that the native ETL platforms, the Airbytes and DBTs, adequately handle 90% of standard schema drift scenarios. Building a custom LangGraph architecture should be strictly reserved for the 10% of cases where the operational logic is so unique that managed tools simply cannot map to it.
Exactly. You do not start by building a bespoke multi-agent architecture. You start with managed tools and only graduate to LangGraph when you hit an absolute immovable wall of complexity.
Okay, so we have mapped the platforms. But stepping back, this entire technological shift introduces a profound structural challenge. We are granting autonomous systems the authority to write production SQL and alter database schemas based on non-deterministic reasoning. This brings us to the final critical topic covered in the source, the governance question and the prompting bottleneck.
Right, because traditional data governance frameworks are fundamentally unequipped for agentic AI. Traditional governance is designed to prevent human error, someone typing the wrong command, or accidentally dropping a table. It is based on deterministic processes.
Right, a Python script executes identically every single time.
Exactly. But LLMs are inherently non-deterministic. The article highlights the core risk. If two different analytics engineers provide the exact same natural language prompt to the same agent on different days, the agent might generate materially different SQL remediation plans based on slight variations in temperature or context weighting.
So how do you perform a compliance audit on a fluid conversation? You can't. If the database is corrupted by a silent, incorrect mapping, say the agent hallucinates that a gross margin field maps to a total revenue field, you can't just pull up the static source code to see what went wrong.
No, you can't. And this necessitates a structural evolution in how enterprises manage data. The article observes that the traditional chief data officer role is rapidly evolving into what it terms an AI COO, an executive responsible for the operational governance of all autonomous agents. Enterprises are being forced to stand up formal AI quality control departments just to manage this non-determinism.
And the primary technical mechanism these departments are enforcing to control non-determinism is a shift towards spec-driven development. How does that mitigate the risk?
It eradicates the reliance on casual, ad hoc, and natural language prompts. You do not manage a production pipeline by typing, "Please fix the meta integration." Instead, engineers author rigid, version-controlled specifications. These are highly structured YAML or JSON documents that explicitly define the allowed operational boundaries, the exact testing criteria that must be met before deployment, and the specific fallback procedures. The agent is forced to ingest and conform to the specification document rather than interpreting a conversational request.
It grounds the non-deterministic engine inside a deterministic set of rules. I like that. But moving to spec-driven development highlights a very human bottleneck, which leads to an interesting tangent highlighted in the datapro.news ecosystem. It discusses the friction of the interface itself, the keyboard.
The cognitive gap between human thought and text input is a massive bottleneck when trying to manage complex agentic systems. A developer can synthesize the context of a broken DAG and a misaligned API payload in seconds, but translating that deep technical context into a structured, comprehensive text prompt takes significant time.
The article highlights tools emerging to solve this, specifically mentioning WhisperFlow, which is a voice-to-text interface engineered explicitly for AI workflows. The underlying premise is that developers think roughly 4 times faster than they type. By using a voice interface optimized for technical jargon and code syntax, an engineer can dictate a highly complex architectural spec, including all their immediate thoughts, structural requirements, and constraints.
And the tool utilizes advanced NLP to parse the dictated stream, remove the conversational filler, structure the logic, and format it into a polished, ready-to-execute specification or prompt. The statistic highlighted is an 89% zero-edit rate on the output.
Wow, 89%. It proves that as the back-end agentic systems become exponentially more complex, the human-computer interface must also evolve to reduce the friction of command and control. Real quick, before we synthesize all of this, the article briefly details why several major platforms did not make the cut for the specific marketing data engineering bake-off.
Yeah, Salesforce Agentforce is heavily marketed, and the source acknowledges its gold standard capabilities for zero ETL operations and PII masking. However, it operates as a walled garden architecture. It is phenomenally powerful if your entire operational logic resides within the Salesforce ecosystem, but it is structurally unsuited to serve as the primary orchestration layer for a heterogeneous stack, pulling from external platforms like Google, Meta, and Snowflake.
And the article also mentions Claude Cowork and Relevance AI.
Both are exceptional for general workflow automation and document processing, but they currently lack the deep, native ETL infrastructure integrations like native DAG parsing and automated sandbox compilation required to handle raw pipeline engineering autonomously.
And Palantir AIP.
Palantir AIP possesses the required architectural depth, but the source notes its operational focus is heavily skewed toward defense logistics, manufacturing supply chains, and heavy industry, rather than the specific semantic nuances and rapid volatility of digital marketing APIs.
All right, let's synthesize the architecture. The core takeaway from the datapro.news evaluation is that a resilient, modern data stack is not a single platform. It is a composite of specialized layers.
Your foundation is the native ETL stack. You rely on the Airbyte context store and the dbt MCP server to maintain structured semantics and execute precise, localized SQL remediation.
When that structured layer encounters raw, undocumented chaos, you deploy Vertex AI and its massive context window to the edge of the ingestion layer to perform schema archaeology and map the unknown.
You mandate architectures like NemoClaw's privacy router to programmatically classify data streams and ensure sensitive PII never reaches public cloud endpoints.
You deploy Copilot Studio to natively embed the review and approval workflows directly into the business user's dashboard environment, eliminating context switching.
And you reserve the immense engineering effort of building custom LangGraph or autogen orchestration purely for the most complex, bespoke internal routing challenges.
The article closes with a foundational challenge to data engineering teams. The productivity advantage in 2026 will not be determined by which organization purchased access to the most advanced LLM.
No, the differentiator is entirely reliant on unglamorous foundational data hygiene. If your enterprise lacks clean metadata, if you do not have a rigidly governed semantic layer, and if you are not utilizing structured, version-controlled specifications, an agentic system cannot help you. It will simply automate your existing chaos at computational speed. The critical question is your data foundation sufficiently structured for an autonomous agent to reason against it deterministically?
Automating chaos at scale is exactly the disaster we need to avoid. Which leads me to a final thought I want to leave you with, a scenario to consider as you architect these systems. We have spent this entire deep dive analyzing defensive postures. We are building sophisticated agentic layers to protect our internal pipelines from external vendors who unpredictably alter their APIs.
It is an entirely reactive, defensive engineering strategy.
But the vendors, Meta, Google, Salesforce, have access to the exact same agentic technologies. What happens when they deploy agentic AI to dynamically alter and optimize their outbound API schemas in real time? What if their agents begin restructuring their data feeds hourly to maximize their own internal compute efficiencies or to instantly support new ad formats, completely eliminating human-driven release cycles?
That's a terrifying thought.
Yeah.
The frequency of schema drift would accelerate from a weekly nuisance to a continuous real-time stream of structural mutations.
We are potentially heading toward an automated invisible arms race, an environment where our internal ETL agents are locked in a continuous, high-speed negotiation with the vendor's API agents, dynamically rewriting and translating data schemas thousands of times a day. We are building the data infrastructure equivalent of algorithmic high-frequency trading, but applied to the basic ingestion of marketing metrics. It is a paradigm shift that fundamentally removes the human from the pipeline, something to deeply consider the next time a single altered column breaks your dashboard. Ensure your foundational metadata is immaculate, standardize your semantic definitions rigidly, and prepare your architecture for a landscape that is only going to accelerate.
The foundation dictates the capability.
Thank you for joining us for this deep dive into the mechanics of agentic data management. Keep your pipelines resilient, and we will catch you on the next deep dive.